The intros of these videos are so awkward, I never know how to start them, but we've got section 5.7 here. We're going to talk about complex fractions. Okay, so complex fractions sounds really complicated. Of course, it seems a little scary. All right, what it is, it's actually just fractions within fractions within fractions within fractions, just lots of fractions everywhere. Look at number one, there are lots of fractions going on. Okay, so I'm going to show you two methods to simplify these. It's actually not overly difficult. There's a good way to really break this down into really just combining what we did in 5.5 and 5.6. Okay, so there's two methods to do this. We've got this first one here is simplify the numerator and the denominator first, then divide. Okay, that's like combining 5.5 and 5.6, or you can kind of cheat, quote unquote, and multiply everything, top and bottom, by the least common denominator of each fraction. You'll probably like that method more, but I'll show you both in this first example, and then I'll kind of alternate as we move on after that, and you can decide which one you like better. Okay, so this first one here, method one. All right, here's the first method on how to do this. Okay, we're going to do it with this simplifying way, working with numerator and denominator separately. So we're going to rewrite this as 3/4 minus 1/8 divided by 2 plus 1/12. Okay, so if we write it that way, basically now we see that this is just a dividing fractions problem, right? So what we need to do is we have to simplify this parentheses, then simplify that parentheses, and then copy that flop. Okay, it's not overly complicated, especially for a problem like this, with just little numbers. All right, so you should be able to do very quickly. 3/4, you know, 6/8. 6/8 minus 1/8 is 5/8 divided by 24/12 minus 1/12 is 23/12. Okay, copy dot flop. So we have 5/8 times 12 over 23. Oh shoot, it's supposed to be 25. I'm dumb. I'm subtracting instead of adding because I don't have a brain. Okay, 25 over 12. Okay, so you multiply by 12 over 25. All right, now we can reduce some stuff. So the 5 becomes a 1, 25 becomes 5, 12 becomes 3, 8 becomes 2, and we get 3/10 for our answer. Okay, not too bad. Method 2 here. Here's the quote-unquote, I think of it as cheating version, so if you like that kind of stuff, you might like this method. Okay, so we're going to write out this whole dealio, big, giant, complex fraction. I'm going to write 2 as 2 over 1. I always write whole numbers as 2 over 1 when I know I'm working with fractions. Okay, so what you're going to do is you got to find the least common denominator between 1, 4, 8, and 12. Right? You should come up with 24. So what we do is we multiply both the top and the bottom by 24. Okay, because you multiply everything by 24, top and bottom, then you're really just multiplying by 1, which means you're not messing with the fraction itself, which is great. All right, so when you do this, you're going to get the 4, cancels out with 24, so it becomes a 1, 24 becomes 6, so 6 times 3 gives you 18. And with the 8 will cancel out with 24, 24 becomes 3, so we'll have 18 minus 3 on top. And in the bottom, we have 24 times 2 is 48. And 24 divided by 12 is 2. So we have 15 over 50, which reduces to 3/10. Okay, get the exact same answer either way. Now, those are the two methods. They're about the same length. All right, whatever one works better for you, go ahead and work with that. All right, I'm just going to flip and keep going. Do kind of just change each time. All right, so this one right here, because I have two whole numbers, I think it's easier to, rather than try to subtract these fractions, it's probably easier to just find the very simple common denominator of 4 and multiply everything by 4. So I'm going to go ahead and do that. Alright, so I know I'm going to multiply by 4 over 4. Alright, remember you got to multiply the whole thing, so you got to distribute. And so we'll have 8 minus 2 over 4 minus 1, which is 10 over 3. Oh, I can't even subtract today. I apologize for being the worst. Okay, 6 over 3. 8 minus 2 is 6 today. Equals 2. All done. Now we'll get into a little bit of variables and there'll be more difficult examples on the back. Okay, I just want to throw in the negative exponents thing as a quick little review. Alright, so I'm going to rewrite this as 1 over r cubed plus 1 over s cubed all over 1 over r plus 1 over s. Okay, now this is a little bit more difficult problem than it looked at the beginning. Okay, so you could, I'm not going to use method 2 for this, I'm going to go ahead and use method 1 just because, I mean, the least common denominator is going to be r cubed, s cubed, so it's going to be kind of the same thing anyway. It'll be a little bit extra work, I think. Okay, so I'm going to rewrite this as 1 over r cubed plus 1 over s cubed divided by 1 over r plus 1 over s. Okay, do these additions. Okay, so the least common denominator here is r cubed, s cubed. So I need to multiply the whole thing by, well, I need to multiply this one by s cubed, multiply that one by r cubed. So we'll have s cubed plus r cubed over r cubed s cubed divided by, least common denominator in the second one here is rs, so I need to multiply this term by s, this term by r, so we have s plus r over rs. Okay, now, and if you get, as you get good at this, you can go straight to the copy dot flop here, okay? You don't have to write it out as the divided like that, okay? But I just wanted to show you what it looks like. So now we can do our division. Oops, that's supposed to be an r cubed s cubed times rs over s plus r. Okay, now we can cancel out 1r and 1r. That'll become a 2. 1s, that'll become a 2. Now, we have to, let's put this together. We'll have s cubed plus r cubed over r squared s squared times s plus r. Now, we know how to do a difference, or a sum of 2 cubes. We know that the sum of 2 cubes is actually s plus r times s squared plus r, minus rs, minus rs plus r squared, which means that our s plus r's are going to cancel out. Okay, so what we'll be left with is s squared minus rs plus r squared all over r squared s squared. And that's as far as you can go. Okay, let's go to more. So this is where it gets a little bit more complicated with all these little guys. Okay, so this first one, okay, I suggest we, let's do it by method 1. Okay, so we're going to work with 1 plus 3 over x plus 2 over x squared divided by, that's a divided by sign, 1 plus 2 over x. Okay, so we got to solve both of these first. We got to get common denominators. Here it's x squared, so multiplied by x squared, multiplied by x, multiplied by 1. On this one, we're going to common denominator is x, multiply that one by x, multiply that one by 1. This is section 5-6 stuff, so if you struggle with it, go ahead and back to that and work it out. Okay, so in the numerator here, we're going to have x squared plus 3x plus 2 all over x squared. And we're going to be multiplying that by the inverse of what we get over here. Okay, so the denominator would be x, so that's going to be our numerator. And on bottom, which would be the top normally, we have x plus 2. Okay, now, we just got to do these. So we've got to cancel an x out, cancel an x out. We need to factor the top here. Factors to x plus 2, x plus 1. And on the denominator, we've got an x and an x plus 2. Those cancel out, and we'll be left with x plus 1 over x. Okay? Just like that. Now, the number 2. Okay, I think, once again, it's probably best for us to use method 1 because we don't even have really a fraction on top. Right? So we'll do 1 minus a divided by 1 over a minus 1. Okay? This first one we don't need to do anything with, the numerator. Okay, the denominator, though, we need to multiply by 1 and multiply by a because that's going to be our common denominator. So 1 minus a over 1 times our common denominator, or our denominator here is a, so that should go on top because multiplying by the inverse. And on bottom we have 1 minus a. Now it's very easy here to see what's going to cancel out. 1 minus a's go away, and we're left with a. Okay, pretty simple problem. Number 3, let's do this one by method 2. So we're going to find the common denominator between all 5 of our fractions here, all 5 of our terms. Alright, so remember this is going to be treated as 2 over 1. Okay, now what we see here is we need x squared times y squared to be our common denominator. So we're going to multiply by x squared, y squared. Multiply the bottom by x squared, y squared. Okay, because that's the common denominator between all 5 of those terms. So we need to distribute that to everywhere. So on top, we're going to have the x squareds cancel out. We're going to be left with a y squared in that first term. And the second term, the y squareds cancel out. We're left with an x squared. And that's over the top of. On the bottom here, we're going to have one y cancel out. But we've got an x squared times x. So we have x cubed y plus, we have one x cancel out, and the second one, 1x. We need to multiply the y squared times the y. So we'll have an xy cubed and plus 2x squared y squared. All right. Now, we got to see if we can factor this, any of these, okay? So the top is obviously a difference of 2 squares, so we can factor that to y plus x, y minus x. And on bottom, all right, we got to start with grouping. So we can group out an xy, and we'll be left with x squared plus 2xy plus y squared. Okay, now x squared plus 2xy plus y squared is actually a perfect square. Okay, so you could factor that further. We have a y plus x still on top, y minus x, and on bottom we'll have xy times x plus y squared. Okay, double check my math in case you don't see that. Make sure you can factor that down to x plus y squared. Okay, so we'll have 1x plus y cancel out, and we'll be left with y minus x over xy times x plus y. And that's the final answer to that one. Now the last problem here, number 4. All right, we're going to go ahead and do one more with, let's just multiply by the common denominator again. All right, do method 2 one more time. Okay, so we need to multiply this top and bottom. We see the common denominator. We luckily have 2 of these with a denominator of 1. Okay, so the common denominator is just k minus 2. So we're going to multiply top and bottom by k minus 2 over k minus 2. Okay, so k times k minus 2, we're just going to leave it like that because we know we need to simplify as much as we can. Actually, we could probably distribute. Yeah, let's do the distribution right away. Okay, so we'll have k squared minus 2k. Okay, from this first one. The second one, k minus 2's cancel out. We're just left with plus 1. On the bottom, okay, this first one, the k minus 2's cancel out. We're just left with a k squared. And the second one, we've got plus k minus 2. All right, now we got to factor as much as we can and try to simplify. Factor this top, we're going to get k minus 1 squared, k minus 1 times k minus 1. And on the bottom, we'll have a k plus 2, k minus 1. How did I know that? Because I saw a k minus 1 on top, so I figured it's probably going to be k minus 1 on bottom, then I check my answer, and I see that it is indeed. So when my k minus 1s are going to go away, we're left with k minus 1 over k plus 2. That's the final answer. Okay, it looks complicated, but it's not as bad as it looks. Good luck, guys.